Hello students, hope you are doing well. So in this lecture we'll be seeing the concept of passing and returning the objects in C++. So in C++ objects can be passed as arguments and returned from a function exactly in the same way as any other arguments are passed or returned. Okay, so you have just seen in the concept of functions that how we are just passing the arguments inside the function and how we are returning these arguments from the function. So in the same way we can just pass the objects as arguments and can retrieve these objects, okay, or you can say can return these objects that we have passed from the function. So the general syntax, okay, if I just say that what is the syntax in this case, so the general syntax in this case is the name of the function. Okay, so the syntax is the function name, okay, function name, and in the function name or in the function we just pass the object. The object is being passed as an argument, so this is an argument that we have passed, okay, and this is the object. So an object has been passed as an argument and we will just see that how we will return this object, okay, from the function. So in order to understand this concept, okay, we just see an example. So the example is that we are more interested in, okay, adding two complex numbers. Okay, so this is a basic example for general understanding because this concept can be understandable by, okay, this particular example. Okay, so it is like, for example, I have, okay, two numbers, okay, 10 comma 20, okay, and these are two numbers 40 comma 30, for example. Okay, so these are basically what I have done. I have just passed these numbers or these constants, okay, as an argument. So for example, there is an object, okay, so for example this is an object C1 and this is an object C2. Okay, so C1 and C2 corresponds to the object. So what I have taken, I have just passed some arguments, okay, inside, okay, when I'm creating the object I have just passed in arguments. Okay, so seeing this particular concept that when we are creating an object and at the same time I am assigning certain values, so one thing must be stuck in your mind, that is I am talking about constructor now. Okay, so this is a constructor, then I am talking about that there must be certain constructor, okay, in our program that is used to assign these values. Okay, so now what I'll do, I'll just create, okay, another object. Let us suppose the object is C3. Okay, so my main motto is that this argument, that is this 10, okay, this is, you can say, the real part. This is the real part. Okay, so if I just designate these numbers, so I just write this is A and this is B for C1, this is A and this is B for C2. Okay, so C1 contains, you can say, two arguments, okay, A and B. The value of A is 10, the value of B is 20. Similarly, C2 contains two arguments, A and B. The value of A is 40, the value of B is 30. Now the A means I am talking about this real part. Okay, so this A corresponds to the real part of C1. Okay, similarly this B corresponds to the imaginary part of C1. Okay, so this B is the imaginary part of C1. In the same way, this A of C2, okay, this is the real part and this B corresponds to the imaginary part. Okay, so for example, if I am taking a complex number, so the complex number must be in the form of A plus IB, okay, where this is the real part, okay, and this B is the imaginary part. Okay, so I have just taken a concept that I have just taken two numbers, okay, and I have just, okay, designated these numbers as real and imaginary. Okay, so if this 10 is the real part of this particular object and this 20 is the imaginary part. Okay, so this is, you can say, 10 and 20i, okay, and this is, you can say, 40 and 30i. Okay, so now my main motto is I have to add these complex numbers. Okay, so my main motto is I want to do something like this. I want to add a C1 and a C2. My main motto is this. Okay, though I can't add them directly, but my main motto is to add the contents of C1, okay, to the contents of C2. So what I'll do, okay, I'll just take, for example, this is okay 10 comma 20, okay, and this is for example 30 comma 40. Okay, so my main motto is the real part, okay, this is the real part, it must be added to the real part of this, okay, and this is the imaginary part, this imaginary part must be added to the imaginary part of this. So this is real, and this is, I can say, this is real part, and this is imaginary part. Okay, so I am more interested in adding the real part of one complex number to the real part of another complex number. Okay, and the answer that I am more interested is, okay, I should get 40 plus 60i. Okay, so after addition I am more interested in getting this particular result, that is the addition of two complex numbers. So I have to derive some relation, I have to code, okay, so that I should get something like this. Okay, so I have to do it with the help of, now with the help of some functions, with the help of passing arguments to these functions, with the help of returning certain values from this function. Okay, so I'll be just writing a, you can say, a pseudo code type of thing. Okay, so we'll be just creating the program in the later lectures when we'll just see the practical implementation of this particular code. So for example, let us suppose I have a class test. Okay, for example, I have a class test. You can also consider this as a complex class. Okay, it can be anything. So I'm just creating, okay, two variables, okay, of type local to this particular class. So this is basically a constructor. Okay, so you can assume that there can be a class test, and for this class I am just creating a parameterized constructor. Okay, so for this class test a parameterized constructor has been created. Okay, and there are two variables a and b that are present in our class. Okay, so these are two variables that are present in our class. So for example, this is class test, and these are two private variables, okay, that are, you can say, instance variables of this class test. Okay, so my main motto is, okay, so I have to initialize these variables inside this parameterized constructor. Okay, so as we all know that constructor is used to initialize the instance members. So I'll just assign, okay, value of x to a and the value of y to b. So this is the basic task that I have completed, but this is not the motto. Okay, the motto is, okay, different. So in main, okay, if I am talking about main, so what I'll be doing, I'll be just creating objects for this test. So I am just creating test t1 that contains, okay, certain values, for example 10 comma 20. At the same time I'm also creating a variable t2, okay, or you can say an object t2 of type t test that contains 30 comma 40. Okay, so for these particular constructors the value, the actual arguments have been assigned. Okay, and there is another object t3 I have just created. Okay, so my main motto is, now I have to add these two objects, you can say. Okay, I have to add these two objects, or you can say I have to add the values that are contained inside these objects, because the objects contains the values or the attributes that are associated with the class, and the attribute that is associated with the class here is the instance variable, and these are the values that are corresponding to the instance variables of the class, that is a and b. Okay, so this must be clear to you. So if I write something like this, okay, so kindly watch it, okay, with a more focus, that if I just write t3 is equal to, okay, t1 plus t2. Okay, if I write something like this, then surely the compiler will raise an error. Okay, then surely the compiler will raise an error, and we will see, okay, later on then that why this particular error is being raised by the compiler. Okay, so my main motto is not, okay, to identify that what is the type of the error and why this error has been, okay, produced here. but I can't add these two objects directly. You must just know this. So what I have to do in order to achieve this task, I have to create a certain function. I have to create certain functions so that this particular task must be processed logically. So what I'll do, I'll just rub this, and I'll just create a function add. I've just created a function add. And inside this add function I have just passed t2 as an argument. And I have just put a dot operator here. So it will be read like t1 dot add t2. So it means that t1 is calling add function in which t2 has been passed as an argument. T2 has been passed as an argument, and the value, kindly just focus here, the value that will be returned by this particular operation will be assigned to t3. T1 is calling add function in which t2 has been passed as an argument, and the value of the operation will be returned to this t3. So here you can see this t1. This t1 is the caller object. This is the caller object. And this is the function. This is the function. Inside this function I have just passed t2 as an argument. So here you can see that I am passing an object inside a function as an argument. So here you can see this add is a function that we'll be defining in our program, and inside this I have passed t2 as an argument. And what is t2? T2 is an object. So this is an object, and I have passed this object as an argument inside this particular function, and the value that this function will be returning, it will be reflected to, it will be provided to, it will be returned to t3, that is also an object of type test. So this is the main logic of the program. So I'll just call t3 dot show that I'll be creating in our program. So this is the logic that we have to now proceed. So we have to proceed like this. So now what I'll do now our main task is to create this function. Our main task is to create this add function so that this particular logic must work correctly. So before creating this function, we have to understand the, you can say, the analogy behind this particular function. That what is the prototype of this function. So this add function is returning a so this add function is returning an object of type class. So the return type of this add function must be of type class, that is test, because it is returning something of type test. The argument that we have passed, it is also an object, and object belongs to a class. And we can say the return type of this particular object must also be of type class. So here we are just knowing two things, that the return type of this function must be of type class, and the return type of this particular object is also of type class. So now let's go and create the function. So how we will create the function? Now we'll just come here and we'll just try to create the function. So inside the class I'm just creating the function. You can also create it outside the class with the help of scope variation operator. There is no hi-fi concept in that. So what I'll do, I'll just create a function that is add. The return type of this add is test. And what is inside this add function? Inside this add function I have passed an object, and the return type of the object is also of type test. So it will be like test. And I'll just create any object inside this particular function. Now with the help of this object we have to process the results. So what I'll do, I'll just create a variable, a temporary variable of type test, so that we'll just put the real part and the imaginary part in this particular temporary variable, and this particular variable or the object must be returned to the program. So I just create a temp, and if I just write, okay, temp dot a is equal to, so it means that temp dot a means the real part of a. Okay, real part of a must contains the real part from the object, okay, t1, and the real part from the object t. So we are more interested in adding the real part, okay, of T1 with the real part of T2, and the imaginary part of T1 with the imaginary part of T2. Okay, where T1 and T2 are the objects that are containing A and B. Okay, of they are the instance variables. Okay, so the process is like this. Okay, so this is T1, for example, and this is T2. Okay, so T1 contains A, B, T2 also contains A, B. This is real, this is imaginary, this is real, this is imaginary. Okay, and what I am more interested, okay, this is temp. This is temp, and temp also contains this A and this B. Okay, that is the final result that we are more interested in getting. Okay, so in this particular thing, okay, temp dot A is equal to what I have to write. I have to write A plus T dot A. Okay, so now what is the significance of this line? Okay, so it means that A will be passed directly. Okay, so this A will be passed directly from the T1 object. So this A will be passed directly, okay, to this particular thing. And T dot A means with the help of the object, okay, with the help of the object, we are accessing the real part of T2, because T2 has been passed as an argument, so we cannot access the value of T2 directly. In order to access it, we have to use the object, and with the help of the object, I am just accessing and I am just passing T dot A. Okay, so what A is, okay, A is getting directly into this temp, and T dot A means this T dot A belongs to the real part of T2 that we have to pass as an argument. Okay, so this T dot A is nothing but it is also an A. Okay, but this belongs to T2 and this is the real part of T2, but we cannot assign this A directly because we have passed this as an argument. Okay, because we have passed this as an argument, because we have written it like that T 3 is equal to T1 dot add T2. Okay, so this was the statement that we have written, and here T1, the contents of the T1 are passed implicitly. Okay, so the compiler knows that yes, this is the value of, okay, this is the value that has been stored in the object of T1, so I need not have to worry about this value. It can be passed implicitly. Compiler knows about this particular value, but for this value T2, because we have passed this object, okay, explicitly, okay, we have passed this object explicitly, we have passed it as an argument, so we have to tell the compiler that how this value can be accessed. Okay, so we are telling the compiler with the help of the object, okay, that we have created, and by using the dot operator. Okay, so this is explicit, you can say, declaration. Okay, this is explicitly we are just telling the compiler. In the same way, we can write temp dot b is equal to, this b value will be assigned directly. Okay, so this b value is the value from T1 object. Okay, that is implicit. Okay, that can be assigned directly, that can be accessed directly. Plus in this b value we have to add the b value of the imaginary part of T2, but T2 has been passed as an argument, so this value can be accessed with the object of this T2, that is T. So what I have to write T dot B, because this is an explicit operation. And what I'll do, I'll just return this temp. So this temp will be returned. Okay, so where this temp will be returned, this temp will be returned okay, to this particular T3. Okay, so it will be returned to this particular T3 and will be displaying the value of the contents of the T3 with T3 dot show. So you can also create a function. Okay, you just also create a function that is show, and I'll just create a function void show in which we have to display the final result. Okay, so what you'll write in this function, you'll just write cout, okay, a, and inside this you can write plus I and b. Okay, so the contents will be displayed in the form of a plus ib. Okay, so now I hope the concept is clear to you now. Okay, that how we are returning and passing the value as an argument. Okay, so it is not too tough to understand. Okay, but we have to be more focused that we have to access the value that we are passing as an argument with the help of the object or with the help of a reference variable, or you can say with the help of a reference of that particular object. Okay, so in this particular thing we can also write, okay, we can also write inside this as test %d. We can also create a reference to this particular object. Okay, so by pass by reference also we can access this, and this is a good practice. Okay, so what I think that in order to access all these contents you have to pass the reference. Okay, in order to access the contents you have to pass the reference of that particular object. Okay, so call by reference is used in order to change, okay, or to provide some modification, okay, so that the call function can modify the value of the arguments by using its reference. Okay, so both the concepts are clear, but try to do it with the help of the reference. Okay, so try to do these type of questions with the help of reference. Though if you are just passing the object, it won't say that your program is incorrect, or it won't result in any error in your program. The output will be same in both the cases, but the good programming practice is try to pass the reference. Okay, because reference is also alias to the object. Okay, and with the help of reference you can also you can say call function can also modify the values of the variables. Okay, if there is any type of requirement in your program. Okay, for example, if you are swapping two numbers, then you have to do it by call by reference, because if you are just passing call by value, then the reflected value won't be, okay, the values won't be reflected in your program. Okay, so it is a good programming practice. So we'll see the practical concept, okay, later in this session. Okay, that how we are implementing this code, because I have just created a pseudocode here. So we'll just see the working of this pseudocode with the help of a C++ code. So I hope it is clear to you now. Thanks.